over 3? No, because even though the quadrant's correct, I keep forgetting what I had here. When we had done the range over here yesterday or whatever, the range is between negative pi over 2 and pi over 2. So when we go to the fourth quadrant in this case, we can't go to the fourth quadrant with 5 pi over 3, we've got to go to the fourth quadrant with something else. So, what's the reference angle?
Pi over 3.
What is pi over 3 in the fourth quadrant? And that's our answer. If we're going to the fourth quadrant, it's just the negative of the reference angle.
What if you just like subtract it from 360?
In this case, that works fine.
Alright.
It won't always work fine, but in this case it does.
Wouldn't that be
Yes,
5 pi over
but the range says officially negative pi over 2 to pi over 2. Okay, so we say what quadrants it has to be, but it has to be between negative pi over 2 and pi over 2. And since that is officially not between negative pi over 2 and pi over 2, we have to write it like that. Yes, it's the same angle. That's why I said that's about as tricky as I can get with it.
I have a question.
So how do we get the quadrant from 5 pi over 3? I still don't get that.
The 3 on the bottom means 60 degrees, and we have 5 60s, so we have 300 degrees.
Oh, okay.
300 degrees is between 270 and 360, so it's in quadrant 4.
But I mean, using radians, like we do that.
If we think about it in radians, the way I would probably think of it is pi would be 3 pi over 3, and 2 pi would be 6 pi over 3. And so we have 3 pi over 3, 6 pi over 3. Where is 5 pi over 3? Closer to the 6 pi or closer to the 3 pi?
Closer to the 6.
And so that's why it would be in the fourth quadrant.
Okay.
To be honest with you, I'd probably just change it into degrees
Okay.
that way, but, and the more you get to use it, the better you'll get at it. We okay there? Yep.
So when we do like, so say we get a decimal one, do we just put it in the calculator, and then find what a quadrant is? Like if it's in a negative quadrant?
If we have a decimal one,
Yeah.
the calculator already knows what quadrants it can be in.
So like if we have.
So if we got something like, find the inverse cosine of negative 0.6135, we just type it in the calculator and there's our answer. Because the calculator knows. The calculator knows inverse cosine has to be quadrants 1 or 2. It knows it and it doesn't. So, speaking of which, I was waiting until Katie came back for this one. Okay, something I want to make sure that everybody is aware of, so make sure you are listening. Okay? With the exception of a problem like this, I would basically call this a non-calculator test. In other words, no weasel deals. No scamming around using your calculator to try to come up with the answer that you're pretty sure is correct. Okay? Use the formulas. If you, just give me a minute. If you use the formulas and get the wrong answer, use the formulas wrong, use the wrong formula, whatever, I will be infinitely happier than if you get what appears to be the right answer, but it's magically appeared. Capiche? If you use the calculators and magically get the right answer, you will get 0 points on the problem. I want to make sure we are totally clear with this. All right? No funny business, no messing around, no nothing. I took an hour typing up a sheet just so that you guys would have it. All right? Know how to use it, know what to plug in, which therefore means that you absolutely, positively need to know the chart. Because as we said at the beginning of this part, as we started 7.3, if you don't know the chart on this part, this is all chart stuff. So you've got to know the chart stuff.
Are we allowed to use it for simple math?
Yeah.
Okay.
No, and I'm not trying to say, you'll notice that I didn't say you cannot use a calculator on this test. I'm not saying that. If you get an answer that is the square root of 2 minus the square root of 6 over 4, and you go, well, I really don't know if this is correct. So let me figure out the cosine of 105, 105 degrees, and then plug in square root of 2 minus square root of 6 over 4 and see if I got the same thing. I'm fine with that. That's good. But you better show me how you got the square root of 2 minus the square root of 6 over 4. That way. Okay? But if you want, so yeah, I'm not saying no calculator. I want you to use the calculator to your advantage, but you got to show me that you know what you're doing. Is that understandable? Do you hear where I'm coming from? Are there any questions on that?
So in the directions where you write whether or not to use the calculator on the phone.
Okay? The only type of question that to me it will be okay to use the calculator on is something like this. Nothing else. It will be very obvious. For the most part, I write give exact values. But if I don't write give exact values, that doesn't mean I can use the calculator however I want. It means that I probably forgot to write give exact values. Problem like this, different story. This is the only different story. Okay? Other questions on this? I want to make sure we're all on the same page here. Whether you like it or don't like it, to be honest, is irrelevant. We just all got to be on the same page. Okay? Good? Go, next. What else do you want to talk about?
The one on the board.
The one on the board. Go ahead, do it. That's just a punch into your calculator.
Can we do an add and subtract?
I don't know, what's better around like midnight 05?
Midnight at 5:05.
I could
Midnight
ask you to
05 is
find
when
the
I
cosine
finished.
of 105 degrees. But the funny thing is I could probably ask it 3 different ways. I could say, find the cosine of 105 degrees, which does not in any way, shape, or form mean use your calculator. Does not mean that.
I didn't say that.
It means whichever formula you want to use to find cosine of 105 degrees. Or I could ask you to find the cosine of 105 degrees and use the addition-subtraction formulas to do that. Or I could ask you to find the cosine of 105 degrees and use the half-angle formulas for that. Do whichever of those last two you want to do.
The plus or minus.
Because those are the only, well, go ahead, do.
Let's do both.
I would say at some point doing both is probably a good idea. Interestingly, you'll get 2 different answers. But
They're both right.
they will have the same value. You'll see, go ahead. It's kind of interesting, in my opinion, in my humble opinion.
Two is mine. No.
You need Tylenol?
I have some layers.
Do you need Tylenol?
Oh, Rachel,
I had some
at
sugar.
what
I'm
point,
just really stressed
I'm
out.
gonna,
Because I have Tylenol with me right now.
at what point would you like them? Now, you want them tomorrow, you want them
For headaches, man. Calm down.
But it's like at school, which is ridiculous, but it's fine. My older school used to bring dogs in.
I guess I could have actually ordered it.
May I steal one?
My older school you were allowed to bring You should totally be allowed to, like, the only thing you could have has to have
So if you had an asthma attack, the nurse would have to come and give you the
Yeah, let me just
Yeah.
walk them all the way across the school.
I'm slowly dying out here.
Hopefully you're in the office at the time. think that you're not doing something right now.
We used to, at my older school, because it's so big, we would have emergency buttons and you press it and it immediately contacts the office. And there's a one that's for light emergencies and for extreme emergencies.
Just let people know.
Okay, let me touch on that for just a second. One of the big issues that people
Which
have
one are you doing first?
when they try to use the half angle formula is some people will say, okay, so now I'm gonna find the cosine of 105 over 2. And
No.
that is not correct. What we wanna do
105.
is we wanna say that the
210 over
cosine
2.
of 105 degrees is equal to the cosine of something over 2, and so that
210.
these are exactly the same statement. So therefore, this becomes 210 degrees, which means that when we use the formula, x is 210 degrees. Okay? Because if you try to make x 105, what's going to happen? It ain't going to work very well
60
because
plus 45.
we don't know the cosine of 110 degrees or 105 degrees, right? 105 is not a chart angle in any way. It doesn't have a reference angle that's a chart angle or anything. So, does that make sense? So make sure that these two statements, when you're doing the half angle formula, make sure that cosine of 105 degrees is exactly the same as what's over here. So basically, we're doubling that and putting it on top. Okay? Did that answer what you were asking about?
I like the adding subtracting because we don't have to do this.
I have to stay here till like,
I know,
Late.
like 9 o'clock at night.
ew.
The senior
So as you guys start to look at
Oh, I feel bad for them. Good thing I'm not senior co.
Okay, so cosine of 60 degrees is K over 2.
at what I said,
Cosine? Yes.
chart this like that, reasonable how
0. I'm just guessing numbers at this point. Please tell me.
on the chart, certainly this part.
So memorize the chart tonight.
And 45 I know is 2 over 2. I always get those two mixed up.
Why is the bed so big?
You're in purpose right now.
Sine of 60 degrees
Now it's
is
just fine.
3 over 2.
I drew this chick, but
Sine of 45 degrees
the surrounding is too big. The bed looks massive,
is root 2 over 2.
but it's not. In fact, she only takes up half.
6. So it's just root 2. 6 over 4. Alright, let's do double angle. Or half angle. Or I want to see what answer we get. It's interesting. It's about I'm trying to find cosine. So cosine 210 over 2 equals plus or minus the square root plus the cosine of 210.
Reference equals 60.
How did you figure out 60?
Because I have just a picture of the graph in my head.
Do it.
Okay, but how do you picture it?
Oh, it's not 60, sorry.
Like here.
This is 90, this is 80.
Oh, I feel bad. Sorry, guys. Good to.
Go straight forward. All right, should I go? Okay, so what's x? 210. By the way, on the formula sheet, I use alphas everywhere. So instead of x's, which are here on the formula sheet tomorrow, there'll be alphas. Doesn't matter, right? And then over here, we have the alpha plus beta. So
That's what I did wrong. No, it's
cosine of 210 degrees over 2 is equal to plus or minus the square root of 1 plus the cosine 210 degrees over 2. So the key here is, what is cosine of 210 degrees? Reference angle is 30 degrees, cosine of 30 degrees is square root of 3 over 2. Since 210 degrees is in
Quadrant 3.
quadrant 3, that square root of 3 over 2 is
Negative.
negative. So 1 plus negative square root of 3 over 2 over 2. So now it's all cleaning up. So we'll multiply to get rid of the complex fraction. So we got the 2, the 2, the 2, which gives us the square root of 2 plus, those cancel, oh, actually 2 minus, square root of 3 over 4, plus or minus, which becomes plus or minus square root of 2 minus root 3 over 2. And then, since we're finding the cosine of 105 degrees, cosine of 105 degrees, 105 degrees is in the second quadrant, and in the second quadrant, cosine is negative, so there's our answer.
Wait, so does that mean the plus minus is negative too? I mean, the add and subtract, is that way if you do negative?
Well, when we do it this way, and I would assume that we'll do, that you would do 60 degrees plus 45 degrees. So that's going to give us a formula that says cosine of 60 degrees, cosine of 45 degrees, minus sine of 60 degrees, sine of 45 degrees. You'll notice here, there is no plus or minus anywhere here. Okay? We don't have to worry about it. It will take care of itself. The only time that we have to pay attention at the end of the problem to whether it's positive or negative is in the half angle formulas when we have the plus or minus in front. Like even these two, we don't have to, because it'll take care of itself. But these three right here, where it says plus or minus, we have to make a decision at the very end. So cosine of 60 is 1/2, cosine of 45 is 2 over 2, minus sine of 60 is 3 over 2, sine of 45 is 2 over 2, which gives us square root of 2 over 4, minus square root of 6 over 4, which gives us square root of 2 minus square root of 6 over 4. Which is interesting because we did the same problem,
And they're different answers.
we got two different answers. And we did everything right, and if you plug this answer and this answer into a calculator, you will find they have the same value. Yep.
So my question is, are you just gonna put cosine of 105 and then we can do whatever we
And that's a
want?
great question. Okay, so, as I said, I can ask this question in three ways. I can either say, what's the cosine of 105, and then follow whatever you do. Or I can say, use the addition and subtraction formulas, in case I know what you should get. Or use half angle, and you should get this. If there is a problem, especially one of the tangent half angle problems, or one of the cosine double angle problems, where you could use multiple formulas and therefore conceivably get different answers, that happened here in the homework a couple times, I will do it the way that I want to do it, but if I see that you're doing it a different way, and therefore get a different answer, I'll go figure it out, and I'll make sure. And if your answer is the same as my answer, and you got it correctly using the formula correctly, absolutely, 100% fine. Yes, sir? I don't know. You know when we'll find that out?
Does it say so? Tomorrow.
1:43 tomorrow, right? 1:43 tomorrow. So, on this one, so we go back to the original problem. So cosine of 105 degrees. 105 is in the second quadrant. Cosine in the second quadrant is negative, so it's negative. So we just do the whole quadrant thing, but from the original problem, not from 210 or anything, but from the original problem. Okay? Should I try one more?
You have 3 minutes.
Cool. The one that we haven't touched on yet, which I kind of expected to, but probably more a me thing, is something like the cosine of 2 times the inverse tangent of 12/5.
Oh yeah, wasn't this a homework problem? I was confused.
Oh, I don't know, I just, could have been.
What is 5?
What is this?
Well, look at it.
What is this?
Theta.
Theta, alpha, x, whatever. It's an angle. So if we called that alpha, then what are we trying to find?
Cosine of 2 alpha.
The cosine of 2 alpha, which, last I checked, is a formula. Cosine of 2 alpha. Oh, we can do any of those. Why don't I do 2 cosine squared of alpha minus 1. Didn't matter which one we used, I just grabbed one. So, equals 2 times, ooh, what's the cosine of alpha? Triangle. 12, 5, right? Tangent, 12, 5, which makes that 13. So, cosine squared of alpha. What's the cosine of alpha? 5 over 13 squared minus 1. 2 times 5/13 squared is 25 over 169 minus 1, which gives us 50 over 169 minus 1, which gives us negative 119 over 169. And there we go. So the key was to remember that this whole thing is just an angle, it's alpha. And once we know it's alpha, we then realize it's the cosine of 2 alpha, and we can find the formula for that. Why what? It's an angle. That 2, I don't like that 2. And when I see that 2, it makes me stop and go, what's going on here? And so, once I have to do that, then I say, okay, this is an angle.